Hi everyone, today I'm going to be showing you how to solve problem 24 from the AMC8 and also problem 25 from the AMC8 in the year 2018. Problem 24 says in the cube ABCDEFGH with opposite vertices C and E, J and I are the midpoints of segments F, B, and HD respectively. Let R be the ratio of the area of the cross-section EGCI to the area of one of the faces on the cube. What is R squared? So first we're going to find the area of EGCI, and we can see that this is a rhombus. And to find the area of a rhombus, you take both diagonals, multiply them, and you multiply them, and then you divide by 2. Yeah. So basically, we can find the diagonals by the Pythagorean theorem. So we know that EC is is equal to square root 3, because if we say one side is 1, then this is also 1. This is square root 2. So square root 2 plus 1, so square root 2 squared plus 1 squared equals 3, and then you square root that. So you get EC equals square root 3. So now we need to find what JI is, and JI is the same as BD, which is the same as AC. So JI equals square root 2. So now square root 3 times square root 2 equals square root 6. We need to do that over 2. And this is the area of this rhombus. And now since one side of the cube is 1 times 1, one side of the cube is 1. So it's square root 6 over 2 to 1, which is just square root 6 over 2. So now square root 6 over 2 squared equals 6 over 4, giving you 3 over 2. So that's the first question. Well, that's problem 24. And now we're going to move on to problem 25. Now, if you guys have any other questions about other problems from different years, feel free to ask me and I'll review them. So problem 24 was C. Anyways, we're going to move on to problem 25. Problem 25 says, how many perfect cubes lie between 2 to the 8th plus 1 to 2 to the 18th plus 1 inclusive? So this problem seems very tricky because 2 to the 18th plus 1 is a huge number. So let's start with 2 to the 8th plus 1, and then let's work on 2 to the 18th plus 1. So we know 2 to the 8th is 256, so plus 1 equals 257. So the lower boundary is 257. The lowest boundary is 257, and the high boundary is 2 to the 18th plus 1. And we need to see how many cubes are in this range. So we can see that 7 cubed, which is 343, is the smallest number cubed that is greater than 257. Now we have to work on 7 to the 18th plus 1, 2 to the 18th plus 1, 2 to the 18th plus 1. Now this looks really tricky, but you can realize that 18 is divisible by 3. So what you could say 2 to the 18th was, you could say it equals 2 to the 6th to the 3rd. And now you can realize that this is basically 2 to the 6th cubed, and we know that 2 to the 6th is 64. So the higher boundary is 64 cubed plus 1. So the amount of cubes is 64, or the amount of cubes is the numbers in 7 to 64 inclusive. So to count all these numbers, we do 64 minus 7 plus 1, which gives us 58. And that's our final answer. So I hope you like this video. If you have any questions, feel free to comment down below. Please like and subscribe if you want to see more videos. You can also comment down below. And good luck on the AMC 8. Thank you. Bye.